What is up, everybody? It is pre-calc time. Time to get back into conic sections, and I'm very excited for this segment from today. We are in Conics Packet 2, page 6, and finally, at long last, we've spent most of the unit kind of ignoring conics that have this XY term. I see it in number 2. And on this sheet, I just want to introduce you to it. I want to let you know that it's out there. This is a type of conic that we haven't spent a lot of time studying, but there are conic sections all over this page that will kind of deceive you into thinking you have one type of picture and it's actually another. Your joke for the day, I learned this one a long time ago. So, how much does a hipster weigh? An Instagram. One of my faves. In the warm up here, try it first. Use the principles we used in the previous lesson to classify these conic sections. So you decide. Okay, so let's look. Number 1, I see only an x is squared. I feel pretty safe in saying this is a parabola, right? Only an x squared term present, not a y squared term. Pretty confident. And that's the type of conic that we've been studying in general form. With number 2, can you circle and star it? I want to say maybe an ellipse. But can you write that there with maybe 2 question marks? We've been talking about a general form. I'm going to scroll this down. We've been talking about a general form that has all this here, but B has always been 0 for us. We've always left it out. Now, it is possible for a conic section to have a B value that's not 0. When B is not 0, what happens to the conic? I have a couple like little diagrams from textbooks that I put at the top of the page. The conic gets tilted. Your transverse and conjugate axes in this top picture are just not parallel to the coordinate axes. They're not vertical and horizontal. We've rotated by 60 degrees. Same thing with this ellipse. You can barely see that equation there, but there is an XY term, and that's going to cause this size ellipse to tilt so your major axis is diagonal, as is your minor, going the other way. Now, we don't need to get into the nitty-gritty about graphing each of these. That's a little further than we need to go. I just want to give you a little quick way to still be able to classify and to get an answer for a question like number 2, and I'll actually just spoil it for you. It's actually not an ellipse. It's not what you think it's going to be, and it's using something that you learned about back in algebra, the discriminant of an equation or a function. Now, discriminants like we used to know and love were just that b squared minus 4ac part that was inside of the radical using quadratic formula, right? We'll talk a bit about quadratic formula today. But here we're using these capital coefficients, a through f, and this conic section actually has a discriminant. Its discriminant is going to be the same, but with capital letters. B squared minus 4ac is still the discriminant here. Oops, I don't know why I put a D after it. How about just 4ac? Maybe I was thinking D for discriminant. If b squared minus 4ac is a negative number, you can trust that you're always going to have an ellipse. So I can, or some type of ellipse, but I'll put a circle here. It's a circle if A and C are the same number. That reminds me of just classifying conic sections. And it is an ellipse in general if A and C are not the exact same value. So that's if the discriminant is negative. Discriminant is positive, maybe you can guess, it's a hyperbola. If the discriminant equals 0, this is sometimes the weirdest one, you get a parabola. So using this new technique, we only need this technique on this page of the packet. This is the only page in the entire packet that has a couple examples of conic sections in a general form with an XY term. But it's kind of cool to see that the calculation's kind of quick to figure out which is which. So for example, if I look at number 3, I get the discriminant first. So b squared, the b is sitting with the xy term, right? So negative 5 squared is 25, minus 4 times a, which is 4, and c, which is 16. So 4 and 16. Really, it doesn't matter what this number is. It matters what the sign of this number is. So if that's negative 231, it's less than 0. My key tells me that that actually makes this an ellipse. I'll put E for ellipse. Ellipse is what I would have guessed for this one because I would have, with our old way, you've got the same sign of your x squared and your y squared coefficient. So not too surprising that this is an ellipse. Is the next one ellipse? I would have guessed ellipse just by a glance. Let's confirm it because of that xy term with the discriminant. So b squared minus 4 times 1 times 3. So this comes out to be negative 3, which is less than 0. You get an ellipse again, which we would have suspected. Moving right down. How about discriminants for 5? Actually, if you want to pause the video, maybe you can get 4 discriminants for 5, 6, 7, and 8. I'll show the plugin for 5. You got the square root there. So b squared is 4 squared times square root of 3 squared, that whole thing, minus 4 times 3 times negative 1. And we'll see what that is. So 48, it's ending up going to be plus 12, gives you a 60. You are greater than 0 for a discriminant. This should be a hyperbola. Would we have guessed hyperbola? Yeah, I would have guessed it because I see that the x squared and the y squared terms have opposite signs, so not very surprising. In 6, try the plug-in, b squared minus 4ac, 25 minus 4 times 8 times negative 4, and you get 153. Greater than 0 again, another hyperbola on our hands, another one that we would have guessed. You've got opposite signs. So far nothing's been too surprising. 7 and 8. 7 looks like an ellipse, is it? Try the plug-in. You get a discriminant of negative 31 less than 0, should confirm that that one's an ellipse. And then 8 is the one I want to star. This is the first time I'm kind of surprised. What are you expecting for number 8? If I just looked at these two terms, it's misleading. It looks like an ellipse. Same sign, but different coefficients. But check out the discriminant. You're just looking at the x squared term, the xy term, and then the y squared term. So b squared, another 16 times 3, minus 4 times 2 times 6, doesn't give you what would make an ellipse. I think it gives you 0. 48 minus 48, right? 0, if I look back up at my key, when the discriminant is 0, I get a parabola. So this is a parabola, and this is the first one that's really thrown me off, really shakes up my world to see that you could actually have an x squared term and a y squared term. It's going to create a tilted parabola. All 6 of these, if we were to graph them, would be tilted. Now remember I said this page is the anomaly. It's not really what we're studying in this section, but I thought it would still be fun to try to graph one of these on our own. So take a look down at number 9. I actually want to show how this would look a little bit tilted. Now I have the internet and I have a calculator at my disposal. I have Desmos I could graph this on, so that's good. But I still want to see, if I were going to graph it on my calculator, and let's say I don't want to go straight to Desmos, I want to make a few predictions first and show you how you could get it solved for y. It's really cool. Could you at first tell me which conic section we're dealing with? I want to say ellipse, but I know better than that. I know that sometimes these ones are going to trick me. So with that xy term present, the safest bet is to use the discriminant. So we'll say b squared minus 4ac is going to be 36, the xy coefficient, right, squared, minus 4 times 1 times 9. Another sneaky one. 36 minus 36 gives me 0. This should be, surprisingly, a parabola. Now, this isn't a parabola like what we've been studying. I want to see if I can get this into my graphing calculator by solving for y, and this is one of the craziest algebraic feats that we are going to pull together as a class for the entire year. I hope that you're adequately excited. This is so crazy. Does this look like, I know sometimes when I want to solve an equation for what a certain variable is going to be, if I have it in terms of a y equals, like if I have y by itself, and it's a quadratic equation, I can use the quadratic formula. Would you entertain the suggestion that this crazy equation could actually be considered a quadratic equation in terms of y? Because it can. The highest power of y that I see in this conic section equation is y squared. You've got a bunch of other terms, a linear y term, and a bunch of terms, and another xy term, that does have something to do with y, and a bunch of terms that have nothing to do with y. We are going to use, this is crazy, we're going to use the quadratic formula as we know and love it, to solve for y. I'll put solve for y, and get y in terms of x and the other constants, and we can get this into our calculator. Can you rearrange things? Let's put the y squared term first. So 9y squared looks good for your leading term. Next, we want any linear term that has to do with y. So this has to do with plane y to the first power, and that term has to do with plane y to the first power. And I want to combine them and write their coefficient out front. So I'm going to say minus the sum of 6x plus 2 times y. Pretty tricky. We're going to GCF out a y from those coefficients. Next up, we should have anything that has nothing to do with y. And I'll put that in parentheses together. Your ending term is going to have the x squared in it, and it'll have the plus 1 in it. This is a quadratic formula we're going to perform. We're going to solve this for y using a as 9, b as this whole thing, negative, got to remember that, and C as everything else that doesn't have anything to do with y. All right, so this deserves a new color. Let's switch to blue, and let's use the quadratic formula. I don't even trust my line drawing skills. I wonder if I could do this. Give yourself a fraction bar, much easier than freehanding. Back to the blue. Looks good to me. And we've got, we're doing, instead of an x equals, right, we're doing a y equals. So x equals, now I have to think y equals negative b. So the opposite sign of this, so positive 6x plus 2, that's negative b. Plus or minus, now we've got a square root of, and we're going to put b squared minus 4ac in there. So we've got b squared, so you're squaring a negative, so it'll go positive. So I'll put 6x plus 2 positive squared minus 4, a is 9, and c is all this stuff that doesn't have anything to do with y, x squared plus 1. Wild. On the bottom, luckily, we have something easy, all over 2a, so all over 2 times 9, and you get this crazy expression. I think I've used the word crazy a little bit too much today, for what y equals. Let's prove to ourselves that this is going to be a parabola. Now, after all that, I could type this into my calculator in 2 steps. I got to type it, since the TI calculators don't have a plus or minus key, I got to type it in once with the plus and once with the minus. If you're able to access Desmos, you could actually type this whole thing into your calculator. So I'm going to also do this in 2 steps. So we'll solve this as a y equals, so we'll say parentheses. Actually, we don't, parentheses. 6x plus 2. Okay. I won't end the parentheses yet. I'm going to do the plus and then the square root. So square root of, make that a plus. What was in there? 6x plus 2 squared. Are you guys getting excited yet? Minus 4 times 9, so 36. And then x squared plus 1. Okay, and then I'll close the parentheses on the outside. All over, I hope I typed this in right, all over 18. And here's the positive side. You get 1/2 of a tilted parabola, as we had expected from the discriminant. I want to see how good I am at just copying this. Let's see if I can do this. Copy, and I'll put it into my second equation, and I just have to change this sign to a minus, and you get a tilted, let me move this around, a tilted parabola. This is our first one of these, but the discriminant didn't lie. Trust the discriminant that you get a tilted parabola. All right, again, hope you enjoy. Have a good day. See you next time.